Hey guys, welcome back. So today's viewer question is from Big Ed over at Keystone Productions PA, and he left me a comment on my scan tool video, so I'll leave a link to that video down below. So for quite some time Big Ed has been playing cat and mouse with a check engine light and an Evap code, and he just wanted some more information on the subject. So I thought I'd go over the diagnostic troubleshooting tips. I'll talk about the repair a little bit, and then I'll talk about how to confirm and verify the repair actually fixed the problem, so you know that you fixed the problem correctly. So before we get into it, unless you're currently experiencing a check engine light and an Evap code, I recommend you skip this video altogether because it's about to get real boring real quick. And you might want to click on over to King Crown P0451's channel and watch the latest episode of Vic at Night, because I guarantee you it's going to be more entertaining than this video. So real quick, what is Evap? Evap is short for evaporative system or fuel evaporative system. And what is it? Well, back in the day, cars didn't have an Evap system, and they used to just pump the gas right into the tank, and you turn the fuel cap and that was it. But when you put liquid fuel in a tank and it gets warm, a little bit of it turns into gases and it wants to expand. So what they used to do is they used to just vent it right to atmosphere. And then one person said, hey, maybe that's not a good idea. Maybe that's why we have so much smog. Maybe we should come up with something. So that's when the evaporative system came about. And what they did is they try to capture those gases. And then when the car is driven, it routes those gases into the engine to be burned. And so that way it turns them into a slightly less harmful composition, and then it comes out the tailpipe and then it goes to the atmosphere. So that worked great for a few years until it didn't. What they found out is the systems would usually leak or malfunction or not work when they're supposed to, or work when they're not supposed to. So then they came up with this idea to add a computer control system with electronics to monitor it for leaks and to make sure that it's operating properly. And that works great until it doesn't. And then that's why poor Ed is chasing this check engine light, every few months. So Big Ed, he's got this code on his car, and the code is let me show you on this one. Oh yeah, and I should probably tell you what kind of car he has. So Big Ed has a 2010 Crown Victoria Police Interceptor model, and the code he's having is a P0451 Evaporative Emission Control System Pressure Sensor Range Performance. So the check engine light will come on, and then he'll hook up his scan tool and turn off the light, and it'll stay off for about 3 months, and then about 3 months time it'll come back on, and it's the same code, and he just does the same thing over again. He just clears it, ignores it for 3 months, and then it comes back, and so forth. So obviously it's some type of intermittent problem, or maybe he's doing a lot of short trips and the car doesn't get to the drive cycle for that monitor, so it doesn't turn on the check engine light until he meets the correct criteria. So I looked up the code in my service literature here, and I'll read this description to you. It says, this diagnostic trouble code sets if the fuel tank pressure sensor does not respond to a pressure change in the Evap system. And under here it says possible causes. The fuel tank pressure switch is stuck open or stuck closed. And then it also lists intermittent or open short in the fuel tank pressure sensor or the fuel tank pressure sensor signal wire. contaminated or damaged sensor, and then last, damaged powertrain control module. But I doubt it's that because he doesn't have any other drivability issues, and it doesn't affect the way the car drives, and he's got no other drivability issues. It's just that check engine light once every 3 months. So down here it says diagnostic aids. It says with the fuel tank pressure sensor at atmospheric pressure, the live scan data should indicate 0 inches of water. And it says to go to pinpoint test HX. So skipping to pinpoint test HX, it lists these codes right here, and it's got a yes or no question, and it says for DTC P0451, it says go to HX34. So we're going to skip to 34. So now we're skipping to 34, and it gives us a test here. And what we've got to do is we've got to hook up a scan tool, and we've got to monitor the live data for the pressure and vacuum of whatever the tank sensor is seeing. So to do that, we would turn the ignition off, and then you're going to remove the gas cap, and then you're going to turn the ignition on with the engine off, and then you're going to look at this scan tool live data. So it says on PSI here, if it's between negative 0.07 and 0.07, positive 0.07, that should be a good thing, because it says, or no, it's just asking you what the value is, and then once you know the value, then you've got to answer this question, and it says, is the pressure within specification? And if it is within specification, you got to do this. It says check for links or bends in the fuel vapor hoses, tubes between the fuel tank and dust separator. Check the evap canister ports and evap canister vent hose assembly for contamination or debris. Check the dust separator for blockage. Repair as necessary. And then clear the codes, and then repeat the test again. Now that's if you answered it yes, if it is within range. So if it's within range, your problem is going to be in this area here. And if it's not within range and you answer no, it says install a new fuel tank pressure sensor. And that's kind of odd, because it sounds like it's skipping a lot of steps, and I think we are, because it sent us to step 34 and we've just skipped 33 steps. But based on this service literature, it says to replace the fuel tank pressure sensor. So if this was my car, before I did that, I would probably want to check the wires going to the sensor. And I looked it up, and it's a traditional 3-wire system. When one wire is a ground wire, one wire is a system voltage with 12 volts, and then the third wire is a 5-volt reference. And the way you would check this sensor is you could do it 2 ways. You could just test it with your voltmeter at the pin connections by disconnecting it and going key on, engine off, or you can hook up your scan tool and disconnect the sensor and look at the voltage readings for that PID. And what you're looking for is you're looking for either 0 volts or 5 volts, and that'll tell you if the wires going to the sensors, or that'll tell you if the wires going to the sensor are okay or not. So after you did that, then I would replace this sensor. Okay, so that should give you an idea of what you got to do to diagnose it. Now let's talk about the repair procedure. So I looked up how many hours labor to replace the fuel tank pressure sensor, and my service literature says 2.2 hours. And once I saw that, I was like, that seems kind of high. So I clicked on the diagram, and it looks like what you have to do is you have to drop the gas tank in order to access this part right here. Now you might have to drop it, or you might be able to loosen all the straps and bolts and just pull it down a little bit to get to that, but I'm not sure. I've never done this before. So this is the part right here. It's this entire long tube that goes from here all the way to over here, and the sensor is somewhere in here. So I looked up the part, and for Big Ed's 2010 Crown Vic Police Interceptor model, there's two different parts. There's two different pressure sensors. And from my understanding, halfway through the build, the 2009 build year, they revised the part, and so there's two different parts based on the build date of your car. So you would need to find your build date, and that's going to be listed on your Federal Motor Safety label right up here in the top left corner. So this is the one from my car. You can see my car was made November of 2003, and it's a 2004 model year. So you would need this build date in order to order the correct part. So this is the part number right here. It's Apple Whiskey 1 Zebra 9 Charlie 047 Apple. And I put a 9 up here because the second part is only off by one digit. It starts with a 9 instead of an apple. And you can see that it's $270. And to further complicate things, because they changed the part, they also revised the electrical connector, the pigtail that plugs into the sensor, and you would have to buy this too for $35. And that's if you have that different part. So it's either this part for $270 or the one just like it, and then you've also got to change the electrical connector for the new tank sensor. So my luck, it would probably be both of those. So you're looking at $300 for that part. And I also did find this, you know, Dorman to the rescue. And I think we all know how we feel about Dorman parts. You know, sometimes you can get away with them, and sometimes you can't. But this part right here is only $64, and versus $300, this is sounding very attractive. And it's nice of them. They even include the electrical pigtail connector right here. And this little doodad right here, this is the actual sensor. And you can see it only comes with two sections of pipe right here. And how you make this repair with the Dorman kit is what you do is you get into your system, and you basically take some shears or some scissors or a knife, and you basically just cut out the sensor. And then what you do is you take these other pipes and you put in the new sensor with the existing pipes that go to this location here and this location here. So that's probably why it's so much cheaper, because it doesn't come with this entire assembly. It only comes with the actual sensor, and then you've got to cut it and plumb it into your existing plumbing. So that would be up to you if you want to spend the $300 on the OEM part, or $65 for the Dorman part, and then just kind of plumb it in yourself. Okay, so now that we've replaced the part, how do we know we even fixed the problem? Because it takes, it's usually taken 3 months of driving for that check engine light to come back on. So usually in these types of situations, what I do is I like to run the readiness monitor for the Evap. And what that'll do is that will get the PCM to run a self-diagnostic system on the Evap system. And if it passes, the check engine light will not come on. And if it fails and it finds that it's not working properly like it has been, it'll turn the check engine light on. So in order to expedite that 3 months of driving, I would like to do a drive cycle. And so I printed the drive cycle right here, and it's very complicated. You know, there's like 1 through 15 steps here for the general all evap monitors, and then there's a separate page on here of 1 through 10 steps just for the evap. So what I've done is I've circled the most important parts of this, and I came up with a little cheat sheet here. And I didn't realize this, but last year when I had to take my car in for a smog inspection, I checked the monitors and the evap monitor was not ready. And before I take my car down for a smog check, I like to make sure all my monitors are run so that I don't have any surprises down at the smog shop and get a failure. So after I read these steps, it kind of jogged my recollection, and I actually did this last year, and so that's why I'm somewhat familiar with this monitor. So in order to run the evap readiness monitor, you've got to do this drive cycle, and these I've narrowed it down to 6 steps to get this as easy as possible. So number 1, you've got to start with an 8-hour cold soak. So that means you've got to park the car and you've got to let it sit there for 8 hours so that the coolant temperature and the temperature of all the other sensors are equal, or have met thermal equilibrium, so they're all the same, so that they can start off in order to run this monitor. So the second criteria you've got to meet is the ambient temperature has got to be between 40 degrees Fahrenheit and 100 degrees Fahrenheit and be below 8,000 feet of elevation. So keep that in mind. If it's winter where you're at, you can only do this when it's between 40 and 100 degrees Fahrenheit. And the next thing you got to make sure of is the fuel tank should be 1/2 to 3/4 full, and 3/4 full is preferable because it'll get the monitor to run a little bit quicker. Okay, so once you've met those 3 conditions, now you can start the dang drive cycle. So next you got to start the engine and you've got to idle it for 15 seconds. Next you've got to drive at 40 miles per hour until the engine coolant temperature reads at least 170 degrees Fahrenheit. And when I did that, I live close to a country road. I got out on the country road and then I set my cruise control at 42 miles an hour, and I just monitored my temperature until it got to 170 degrees. Now you're probably thinking, you know, how the heck do I do that? Because my temperature gauge only says C and H, cold and hot. Well, more on that later. So I did that, and if you do that, the evap monitor should run in 12 minutes and 30 seconds. And I say that because that's exactly how long it took to run in both of my 04 Crown Vic and my 2010 Grand Marquis. And if it does not run in 30 minutes, you've got to start this whole process all over again, because the evap monitor only runs in the first 30 minutes of this key cycle or drive cycle. All right, so let me take you over to the car and show you how I monitor the temperature. Let me turn this on so we can get some power. Okay, so I've got my little scan tool here, and this is what I use to check my coolant temperature. But as you can see, the screen is barely 2 inches big. So that's why I like to use my Wi-Fi scan tool and then transmit it to my cell phone here, and then I can I have a little bit bigger screen to work with. So when you get ready to do your drive cycle, hook up your Wi-Fi scan tool, and then you can broadcast it to your phone or your tablet or whatever. And because it has a bigger screen, you'll be able to keep an eye on your engine coolant temperature and even your speedometer in a digital format, because if you've got an older car, it's just going to have this analog speedometer. Okay, so as you can see, I've got a clear view of my engine coolant temperature. It's at 60 degrees Fahrenheit. So right now I would be clear to go do a drive cycle. And then there's the miles per hour that you can use to look to make sure you meet that 40 mile per hour speed requirement. Okay, that's pretty much it. Thanks for watching. We'll see you next time. Bye-bye.